Good day, everyone. Welcome to Study with Mr. M, which is known as Math and Science Academy. But what I wanted to do first, my aim or my goal was to firstly start with transformations, which is where we translate and reflect. But I cannot do the other part of functions without doing the last function. I thought I would save this one for the inverses, but I realized that since it is tested also in grade 12, some people may have forgotten the basics. And when I tried to do the revision and try to revise and prepare for this lesson, I realized that there's a lot to unpack on this one. Now, please stick with me. Now, what I want you to do, this is going to be a short video, 10 minutes, just 10 minutes rather. I want you to at least listen to me, watch what I do, and then you can then replay the video, and then so that, because there's a lot of things that I'm going to say and you don't want to skip that because or not hear what I'm saying because you were busy writing. Now it's a short video, let's not make it long, let's just start and get into it. Now, exponential function, a little bit complicated, but there's some blurriness that I want to clear by firstly starting with the real standard form. I've been seeing people writing standard forms, but they exclude the A and they just only consider the B. But I want you to remember this. Come here with me, right? We're going to be doing a lot of examples. If you see over here, we're also going to be drawing. Let me remove this. We're also going to be drawing. Number 1, 2, 3, 4. Also going to be drawing. So please do stick around and let's just work towards mastering this one, because this one will play a bigger role in the topic of inverses. So I don't want you to just brush over it, right? So now, like any other function, we should be having what we call a standard form. Right now, the same standard form that you have for a straight line, a parabola, a hyperbola, is different also with a exponential. Now the exponential will have a standard form that goes like this: y is equal to a multiplied by b, x plus minus p plus minus q. I use plus minuses because it's not always the same, right? But I want you to remember this one thing. You remember p and q. Yes. How do you remember them from a parabola perspective? From a parabola perspective, these were the x and y coordinates of the turning point, right? But when you go to the hyperbola, what did we say about it? We said that these were the asymptotes. This specifically was the vertical asymptote, and this was the horizontal asymptote, if I remember quite nicely. Right now, this will also remain the same. By horizontal, I mean that if you have something like this, it will be this asymptote over here. We spoke about asymptotes, so you know it. Right now, an exponential graph will only have one asymptote, and that is q. Right, so this will be the asymptote that is in the horizontal part, like this, right? And then P will do the same job it does on a parabola and on a hyperbola, but in terms of a hyperbola, of course, we know that it does shift the graph left or right, but we know that it does not touch. That is why we call it a what? An asymptote. Asymptote is the line in a graph that the graph does not touch, right? Now here, which one is asymptote? We're only going to be speaking about this one in terms of asymptote, which is the horizontal asymptote. Right now, I want us to continue with the P. Now P will shift the graph left or right. But don't be confused when I say horizontal asymptotes and say then P shifts to the right. Do they do the same job? No, they don't. I mean, when I say horizontal asymptote, if I have a graph over here, I have to draw my asymptote over here, right? My asymptote over here, it's horizontal. That's why we call it the horizontal asymptote. But when I call it, let's say this is negative 2, I will call this equation y is equal to negative 2. This is the equation of what? Of the asymptote, right? And then this is all you need to know about the asymptote in terms of just an exponential. There's nothing deep. I just want to continue before I get lost in the mix. Now, this is very, very key. Let me use an example. People, when they see something like this, x, then they see that, okay, y is equal to negative 1 over 3 x. Then we have this one. I want us to make these two examples. We'll do them. Let's see. 2x. Then let's see y is equal to negative 2x. Now, I want you to take note over here. The a is always the one that starts first. If you don't see it, it means it is 1. B is the one that carries the exponents. So just because you don't see it over here doesn't mean A is not there. And I'll show you what A does and how a lot of people are confusing A and B. Right? Now, in an exponential, it likes to be a little bit of complicated. Right? So I'll teach you two methods to avoid the confusion. Right? Now, I want you to do this. Right? If you remember that over here I have 1, and over here I also have 1, always put the 1. Always put the 1. But even if you don't show it in an exam or you show it, they're not going to penalize you. Now you have a basic standard type of exponential that is 1, or A rather, that is A, B, and the exponents. Of course, not shifted left or right so that it can be a simple example, right? So also over here, we still have A over here, which is 1, B, which is 2. Now, what is the value of A going to do to the graph? If A is greater than 0, what do I mean? I mean that if A, let's change the color. If A is positive, what is going to happen, say? The graph is going to be the above the x-axis. Now, above the x-axis, what do I mean? I mean that all over here, above, all over here, right? When A is positive. Now, we can say that when A is negative, when A is lesser than 0, meaning it's negative because anything that's lesser than 0 is negative, right? Now, when A is lesser than 0, what is special about this thing? What is special is that the graph will be below the x-axis. What do I mean by below the x-axis? I mean that it will be all the points over here, all the points over here, all the points over here. Now you see the value of A. A just acts as a restrictor to know are we above or below the x-axis. Now, B will act as who? I want you to remember B as a gradient, right? Now, B acts as the gradient. I've shown you how to determine if the gradient is increasing or decreasing, right? Now, I want to teach you something. Don't say, it's a fraction. My graph is going to look like this, right? Because B will show us whether our graph needs to look like this, or whether our graph needs to look like this, or whether our graph has to look like this, or whether our graph has to look like this. B will act as the gradient. It will direct us. Just because A is negative, which is always the 1, or if you are given as 2, whatever, if it is negative, that does not mean now our gradient will be decreasing. If it's positive, it does not mean our gradient will be increasing. I want you to remember it like this. When B is between this interval, meaning when B is a fraction that is lesser than 0, but greater, that is lesser than 1, but greater than 0, the graph will be what? Will be decreasing. Right? Because if you start from here and you go and go and go and go, what is the gradient doing? The gradient is decreasing, right? So we don't look at if B is positive or not. You only look at its value if it is between 1 and 0, meaning it is fractions that are lesser than 1 but also greater than 0, right? Because as you see, B cannot be 0 because it will cancel everything out, right? Now, I want us to take another part of this one. When B is now greater than 1, the gradient of our graph is going to be doing what? Increasing. Right? Now, if you start from here and you go and you climb, what is your gradient doing? Your gradient is increasing. Now, what I want us to conclude is that B is the same as M, because M is what? M, it is the gradient. So it does the same job to tell us whether are we going to be increasing in terms of the gradient or decreasing. Now I want us to do this example over here where we see that 0 is lesser than B. 0 is B rather is lesser than 1 but greater than 0. Right? Now let's say that B is equal to 1 over 3. If you change that, you're going to get 0.33. That is lesser than 1, but it's also greater than 0. So it's between this interval. So it means that our gradient is what? It is decreasing. Right? But now the scenarios, whether it's above or below the x-axis. Now let's take this example over here and try to understand it. Now let's look for the first example where it's above. I said to you, your gradient should be what? Should be decreasing, right? So when you draw your graph, you draw something like this, right? When it's above the x-axis, how are you going to see if it's above? Your A value should be positive, right? Now, if it is below, how are you going to see if it's going to be below? Your A value should be lesser than 0, right? Now, if it's below, how do you make the gradient to decrease? You make the gradient to decrease by forming a slope like this. A slope like this. If you see over here, when you go over here, your gradient is going what? Is going down. It is decreasing. So whether it's above or below, your gradient is B, and if it's between 0 and -1, your gradient should be always what? Decreasing. Right? Now, let's do for the example where A is greater than 1. Let's say, for example, A is equal to 2. 2 is greater than 1. We can't even explain that. Right? Now, let's say, for example, our A is positive, meaning our graph will be what? Above the x-axis. Right? Meaning it will be above. So now our gradient should increase. If you go over here, it's like you're climbing. Your gradient is doing what? It is increasing, right? Now, if you go over here and say that, how is my graph going to look if my B is greater than 1 and my A is below, is negative, meaning below the x-axis? How am I going to show that my gradient is increasing? You do this over here. Because if you go from here all the way, it's like you're climbing. What is your gradient doing? Your gradient is increasing, right? Now, I want you to look at something that I did over there. There was no point in time where I made this graph touch the x-axis. Why? Because we said that this graph specifically only has the horizontal asymptotes. Right? Now, what you must look at in terms of those horizontal asymptotes is that if you do not have the value of Q, your x-axis, which is this one, then becomes your horizontal asymptote. Right? So in a standard form, let's say equation like this where you have 2, y is equal to 2 to the x, right? If you were to find the x-intercepts over here, you would make maybe y equal to 0, say 2 to the x, and you'd find out that there is no x-intercept over here. So you try ahead and go ahead and try to solve for the y-intercept. So you make x equal to 0, then you get that y is equal to 1. So your coordinates would be 0 and 1, right? We've explained that a lot. Now let's say here 0 and 1 would be over here. 0 and 1 would be over here. right? Now, what are we going to do? We're going to remember in our graph, this is our equation, going to be 2x. I always want you to put this thing in a bracket. So you can see that here I have my A and it's positive 1. And then here's my B, which is the gradient. Is it greater than 0? It's greater than 1 rather. Yes, it's greater than 1, meaning my gradient is what? It is positive. It is increasing. So what you're going to do over there is just show them something like this. But you see over here, I did not touch the x-axis. Why? Because this graph over here does not have the value of q, right? There is no q over here. It means that the x-axis is then going to become what? My horizontal asymptote. So my graph must not touch my horizontal asymptote. Are we together? Now, as I said, there's a lot of information that we're unpacking. That's why I want you to always pay careful attention, right? Now, let's do this for example, right? Now, if your graph is above or below, right? Let's say this is your domain, this is your range, domain, range. Now, let's look at above first. When you see a graph that is above over here, you see it's not touching the x-axis because that is our horizontal asymptote, right? Now, if it is above, how do you find your domain? You can see your graph will still continue over here. It will not touch the graph, of course. It will still continue, but it will not touch. It will not touch. It will just get closer to it, but it will not touch. Right? So also the same thing will happen over here. The graph x values will keep going and going and going until infinity. Now, it means that this graph exists for all x values. So we can say that the domain is x is an element of real numbers, right? Now, let's see if the range also corresponds with what we are seeing. Now, the range is the y values where the graph exists. Same with the domain, it is the x values where the graph exists. Now, the y values where the graph exists, you can see it starts from the x-axis or the horizontal asymptote going all the way up to infinity. But because it does not touch the x-axis, the 0 point, we are not going to include that point. We have to say that y is always greater than q. In that case, q would be what? In your example, q would be 0. The y value of your horizontal asymptote, because we know at the x-axis, y is equal to 0. That's how we find the x-intercept, right? Now you see the topics are interlinking. Right? Now, there's a lot of things here, guys. There's a lot of things, but let's keep going. Right? We always say, you know, when it's above, x is an element of real numbers, y is equal to q. But if in that case, our q, which is the asymptote, is the x-axis, and we know that at the x-axis, the y-intercept, the y values are 0 at the x-axis. Right? Now, let's do for the below. For the below, let's say maybe you can either do for decreasing or increasing graph, it will still give you the same thing, right? It will give you the same thing. You can try it. If you do for the graph that is like this, it will still give you the same thing. And also if you do for the graph like this, it'll also be the same domain, right? Now, the domain doesn't change because the graph still does the same thing. We can also see that the graph says x is an element of real numbers because the graph will keep going to the left, keep going to the right till infinity, but it will not touch the x-axis. Right? Now, if you remember again, we said that here we're going to restrict the domain, but now the graph exists for y values that are below the x-axis, starting from the x-axis, because it will get too close, but it will not touch it. So we can't include the x-axis because the y is equal to 0, and we know that is our y asymptote, that is our horizontal asymptote, and the graph must not touch it. The graph doesn't exist at an asymptote. Hence, we are not saying y is greater or equal to q, right? So we can't say it's equal to because at q, it's an asymptote, it does not touch an asymptote. We can't include a place where a graph does not exist, right? Now, range. The range will still be the same. We'll say that the range will be y values that are lesser then q. In that case, y values, the q is 0. That is your range. Right, so you can look at it when it's above and below, and you'll see that is the properties that it follows. Right, now I want us to be able to do something over here. Draw a few graphs, and then you'll draw some of the graphs your own. Right, now this is the step that we're going to be following. Here's the step that we're going to be following. Drawing the graphs. How to draw. First step, I said to you, find x and y intercept. Sometimes the y-intercept is not there, and it's fine if you don't find it, and the x-intercept is not there. Sometimes there's times where you can't solve for the x-intercept, right? So it's fine. You don't have to stress about that. It does happen. As you see, our graphs that we drew over here were always like this, and there was no x-intercept over here, only the y-intercept. Then number 2, right? Determine the gradient. What did I say the gradient is? B. Right? Now, also number 3, determine A. So here A, we're trying to see if it's above or if it's below. Right? You're trying to do all those things. Now, what you're going to do after that is going to say plot asymptote. If it's not there, we know, of course, it is just going to be the x-axis. Now, after that, we're going to say number 5. Which point am I forgetting? Yes, find a random point. Right, find a random point. Substitute into your graph, and then you'll know what to do. Now, let's try and shrink this over here and put it at the corner, so we work with it over there. So let's follow these steps. Now, I want us to draw, right? I want us to draw, and that's all that I want us to do. I want us to be able to draw, right? Did I explain the value of P? Did I explain the value of P? Yeah, I think I did it. Let me think. We had something like this, right? It's something like this, the standard form, plus minus P, plus minus Q. Now, P here will do the same job. When you shift the graphs to the right, you say minus. When you shift the graphs to the left, you say plus. It does the same job as it does in a parabola or any other function that we've discussed where there's a value of P. But of course, in a hyperbola, I would say that it is an asymptote, but it also shifts the graph left or right. Right? So we know that P is just complicated, but we've learned the value of P. I've explained it in a deeper sense in the other videos. Now, first one, it is how to draw. Now, we'll firstly start with this one. Now, what I'm going to have there is that is y is equal to 1 over 2x minus 2 plus 2. Am I looking at it nicely? Yes. Now, the first step, what does the first step say? The first step says that we must find the x and y intercept. So to find the x and y intercept, for the x intercept, right? Now, what you're going to do is going to have y is equal to 1 over 2 x minus 2 minus 2. What you're going to have over there is that you're going to find something like 0 is equal to 1 over 2 x minus 2, right? And minus 2, because we are looking at what? The x-intercept. Who do we make a 0? Y. We made y equal to 0. So let's remove this over here. You see, it's a lot of work for you to even draw, right? Now, you transpose this one to this side, so it becomes positive. So you're going to have 1 over 2x minus 2. Now, what I want you to do here, I want you to just make the bases the same, so you can equate the exponent. I taught you this. If you don't know it, if you want to change a numerator to a denominator to become a numerator, you take the numerator, multiply it. You take the denominator, apply it Hey, what am I saying? Is that I didn't teach this and I'm trying to rush through it. So let me just relax and explain it nicely. Right? It's fine. I'll explain it. It's fine. It's fine. It's fine. Then, if you want to change a fraction to become just a straight a numerator type of thing rather, where you have maybe two, just one, maybe, right? What am I saying? But it will make sense right now. I'm trying to explain. It's hard to explain numbers, guys. And as I'm just joking. Now, what you're going to have here is that you're going to say one. There was a student that was teaching this too. Yeah. I remember. It's fine. Then you're going to say 1 over x, right? You're trying to take the x upward so we can remove the denominator. So you have to multiply the denominator with the numerator, right? But if you remember, the numerator does have an exponent 1 and the denominator does also have an exponent 1. When you take it upwards and multiply it, the numerator, the denominator's exponent becomes negative. Let me show you this. You're going to have something like this. You're going to say 1 multiplied by x is going to be 1, negative 1, right? Because it had 1 as an exponent, so it must become negative 1. What you're going to find there is x minus 1. So you want to change this, you just say 1, then you put the denominator back to its original to its original place, but with a positive exponent. I don't know why my mind is foggy. Please excuse me. Sorry, but I was trying to explain this, and because when you go all over the place trying to explain other things, your mind gets a little bit busy, right? Everything is just trying to process what we are doing. So I want to do it with a physical example because I'm not feeling what I'm doing, right? It's fine. I know we're doing exponents, but this is how we learn, right? We just touch base here and there. Okay, let's do it with let's say 1 over 3. Yeah, 1 over 3. This is nice. 1 over 3. Now, what I said to you is that you multiply, of course, we know that 1, that invisible 1, right? We always do this. We'll say that if you want to change, you're going to say 1, multiply the numerator by the denominator, but make the exponent of the denominator to be negative. So it becomes negative 1. Anything times 1 is that thing. So in this case, it would be 3 minus 1. Put this in your calculator and tell me if you don't get 1 minus 3. 1 over 3 rather, not minus. Okay, right? Also, if you were to change for maybe 1 over x squared, you'd also say the same thing. 1 multiplied by x, make the exponent negative, then what you're going to get is x minus 2. Right? Nah, that's just it, guys. I know we're not here for algebra lessons, but it won't hurt for me to explain while where I can, right? So let's continue with this one. Now, what we're going to have here is 2 to the minus 1. I'm not going to explain that because we just did that, right? Now, when you have a power raised to another power, you multiply the powers, right? So in this case, it's just going to be 2 minus times negative 1, right? So it's going to be negative 1 times x, right? So it's going to be negative x. Then it's going to be negative, what's this? Negative 1 multiplied by negative 2. What you're going to find there is positive 2. Now, the exponents are the same, not the exponents. The bases are the same because you have that invisible one over there. So you can drop that invisible 1, which is 1, is equals to this exponent over here. So it's x plus 2. Then you can take the x to the other side. So it becomes x. This here becomes minus 1 plus 2. What you're going to find is that x is equal to 1. It was a job, right? It was a job. I don't know why it did examples like that. Now, so the x value would be 1 and the y value would be 0. Why? Because it is the x-intercept, right? So now we can go ahead and plot the x-intercept. So we can see the x-intercept is what? It is 1. Let's say it's over here, 1 and 0, right? Of course, you are going to plot the other ones. I'm just going to give you an example. Just an example, then you're going to be doing for all the other 3, right? Now, then what does the next step say? Determine the gradient. Let's look at this equation. Over here. Let's remove all of those things. It was a fun game when I was getting embarrassed by maths, but it's fine. Of course, I said to you, always put it in a bracket. That's why I wrote the examples in a bracket. It means over here, our A is what? Is 1. So our A is positive. So it means our graph must be above. Right? Now, that's fine. Meaning that this is our B. Who is our B? Our B is 1 over 2. If you change 1 over 2, it's 0.5. But if you look at this restriction over here, it means that B is lesser than 1 but greater than 0. It's between this interval. It means that its gradient is going to do what? It is going to decrease. Right? It is going to decrease. Right? Then we know the gradient now is going to look like this. Because it's above, it's going to look like that, right? If we had a graph like this, because it's above, it's going to look like this. But if it was below, of course, it was going to look like this, right? The gradient must decrease either way, whether it's above or below, right? Now, we've checked the gradient, it's fine. They say now determine A, you've determined that it's above. Then they say plot the asymptotes. Do we have our asymptote? Yes, our horizontal asymptote is there. It is 2. It means that the graph has been shifted how many units down? 2 units down, right? 2 units down. So we can plot the horizontal asymptote over there. Let's say it's over there. A straight line. Yep. Yeah, it's fine, right? So we can label it and say that here y is equal to minus 2, right? Then we also have to go ahead and find, we didn't find the y-intercept. I forgot. That's fine. Let's do it. Y-intercept, right? This is a good question. I made it on my own. I know. It's fine. 1 over 2 x minus 2 minus 2. It's fine. Now let's find, let me take out a calculator because I don't want to make mistakes right now. Okay, then let's find the x-intercept. The x-intercept is where we make the y-intercept, rather, is where we make x equal to 0. So it's going to be 0 minus 2 minus 2. Now, put that whole thing in your calculator. Don't try and do a lot of calculations in your head, because in an exam, just like how I am right now, fatigue. I'm explaining the right things, but I'm explaining them in a very weird way, right? So when you put that in your calculator, you find that y is equal to 2, positive 2, positive 2. Now, we're good, right? We're good. I think we're good, right? Now, this is going to be positive 2, so meaning our coordinates will be just 0 and 2. Why is it 0 and 2? Because it is our y-intercept. So our x-coordinate should be what? 0. Now, 2, let's say 2 is over here. So we can say that this is 0 and 2. Now, we said that our gradient is what? Is decreasing. So what we must do to find the shape over there, let's try and do this so we can plot. Of course, if you want to do this one, the last point, find a random point. How do you find a random point? Let's just say substitute 1, right? Substitute where x is equal to 1. So you're going to say that over there, just remove all of this, stuff. What you're going to find is that you're going to say that where y is equal to 1 over 2, then we're going to say that 1, put 1, this is x, where there's x, right? Minus 2. Then what you're going to find there is that y is equal to 0. It means that when you put y, you're going to get a x value of 1, but a y value of 0. So that is the random point, or you can substitute 2. But I was down for substituting 1 because I saw already 1 had a y value of 0, but it's fine. We learn every day, right? Now, because we said that the A is positive, meaning it's above, but the B is the negative gradient because it's between 1 and 0. What we're going to do is do a graph like this. Of course, does not connect perfectly. It does not touch. You see, the graph does not touch. It gets close, but it does not touch. Of course, over here you would label your graph Mr. M. I'm just joking, right? Now, I'm sure you understand what I'm doing. We apply the same principle of this thing, right? Apply the same principle. Now, for a random point, I just want you to substitute a point that is not on the graph already, like I did. So let's say you substitute y is equal to 2, where x is equal to 2. Usually x is the easier one to substitute. So please, let's do that, everyone. Here are the graphs. We already drew this one, right? Use the same principles that I did to just apply the knowledge, right? Of course, I did. I did not this one, not this one. You do all of these, all of these, all of these. Then you can send them to me on my WhatsApp or whatever, TikTok. You can send it to me and I can confirm if it's correct. Because if I draw the graphs continuous, it's going to be a spoon feeding fest, and I don't do that over here. I think that was a brief. That was not a short one. I said I would just waste 10 minutes of your time. I think I just took all of your time, but it's just revision, and I think this signals the end of exponential functions, and what will follow is just the reflections, and after the reflections we get into the interesting stuff, which is just investors. Goodbye. See you next time.